Hello everyone, doing another video here, this time kind of a bit dual purpose. On one hand I'm going to be showing a new feature that I put in, and on the other hand I'm going to be doing a bit of a tutorial on the behavior tree system in general, because I kind of spent a lot of time working it out and there's not that much in the way of tutorials or documentation, and trying to get some complex behavior can be a real big pain. So yeah. Basically, I'm just going to go through my behavior tree setup and explain why things are the way they are as I go. So obviously you have your root node, you come down into this selector, and so I've got some, just starting really simply, putting decorators on. Decorators are just conditional checks. Custom decorators, I think they're broken. You used to be able to call, conditions succeed or fail. But they weren't really useful because you couldn't set the abort settings. Now you can set the abort settings, but you can no longer call succeed or fail. This is 4.7.6, so hopefully that changes. Or maybe they've just renamed it and I can't find it, but I can't figure out how to do custom decorators, but that's right, I've just been using the Blackboard ones. So we have obviously our Blackboard hooked up to the behavior tree. Here's kind of our keys down here, so I've got, should run behavior, target point, attack target. Is an attack range? Is it target point? Self factor auto generates. If you delete it, it just comes back. I don't know what it is. Can attack and has direct order. Direct order is the new feature I put in today. We'll kind of go through everything just because I haven't actually covered my behavior tree setup. So very first thing here is we have a should run behavior. So obviously really simple. This gives you the ability to, if you ever set should run behavior false, it'll just sit on this 99-second wait. It'll just do nothing forever, which is good. I use it when things die or when things kind of have custom behavior, like in the catch fire, kind of run around panicky. I decided not to put that in the behavior tree. I put it just as a bunch of move to commands on the controller, and just kind of while that's running, I just tell the behavior tree to do absolutely nothing, which is just a wait mode renamed. The controllers don't really like stopping and starting behavior trees. I get the feeling that behind the scenes that's really non-trivial, so I tend to try and keep the behavior tree running. Just sitting on a wait node takes no effort at all. And you'll notice a lot of my wait nodes have like a 99-second wait time. Not some of these, but 99 seconds, 99 seconds. This is because it's basically just there as an ultimate failsafe. It'll always get just cut out of that by the abort settings, which are fantastic. The event-driven nature of the behavior tree is really good. So first of all, really simply, if should run behavior, come down this tree. If not, do absolutely nothing. The reason we need this is not on this node when we have the is set on this node, because originally I just had the is set here. If you don't have this is not set, when it finishes any one task, the way it works, it'll succeed or fail back up the tree. So let's say, it moved to its target point and succeeded, so this node succeeds. It'll just go succeeded, doesn't meet conditions, run the next, and it'll end up actually running this do absolutely nothing. And since the value for if should run behavior doesn't change, it doesn't get a chance to trigger this abort. So you do need that protected there. So I've got, actually, I'll stick with my own naming conventions. I've got all these nodes that start with check. The check exists generally for that purpose. The check just means, don't come down here if just because you've kind of succeeded some other stuff. So do nothing is nice for cancelling the behavior tree without physically calling stop logic, I think it is. Now in here we've got some base cases, so let's move this up a bit. What we have is we have target point, which is where we want to move to. We've got an attack target, and then we've got this new system I have called direct order. So I guess I'll show just really quickly what the new feature is. So basically, following on from my last video with the formations, if I just kind of dump a bunch of guys, 4, 5, sure, and a couple of, where are my archers? 1, 2, So I get a bunch of guys, and I give a move to command. That's all sweet. They move up with like their new awesome formations that I love. So that's awesome. Warriors in the front, archers in the back. Now the problem that I was going to have here is that the second we get a, let's have one lonely guy down here on team 2. Now he's going to chase after these guys, but basically I have these nice neat formations, but the second they see someone, that's because I've actually fixed it, sorry, because I am issuing direct orders. Without this new feature, the problem is the instant they see him, they'll forget all about doing what I say, and I keep botching up the commands, sorry. So I want them to be in these nice formations. But if they turn around, the second they get the attack target, they will break formation, which might not always be what I want, basically. So what I want, if I come down now and hit this direct order button, and this time if I do this same test, they'll actually stand there, and the ones that can shoot there will, but they will actually stay in formation. This is really useful in some situations particularly, so the one I can think of is, if I have an archer, they have a warrior. Now I'm going to start shooting at him, he's going to start running at my guy. Now that I give this move to command, he will actually strafe or backpedal, because I've got the 2D blend space set up. He'll actually backpedal while still shooting at that guy, which is something previously that he wouldn't have done. He would have sat still because he would ignore the target point since he has an attack target. So basically, what we have is a move to command and an attack move command, which, you know, kind of standard for RTSs and stuff. With those two things, you have a lot of power over what you want to do. So that's all the behavior that I wanted here. We have targets that should be ignored, like so attack move commands, which gives you a target point that should be ignored when you get an attack target. They should just chase after their attack target. We have attack targets, obviously, and then we have the what I'm calling direct orders, but what is functionally a non-attack move, just a normal move, which is attack if you're in range, but your main objective is to move to this point. And the tricky part of that was actually getting them to be able to attack while they moved there, just cancelling the attack target and moving, doing simple. So, ultimately, the order of priority that comes down to is, number one over here is, do we have a direct order? So one of our big checks here is, has a direct order. The direct order is set, we want to do this. And then the only other, if I'm going to set this up a bit more like a tree, actually, it'd be a little more obvious, but so we have has a direct order, does not have a direct order. Well, I'll get to why I've called these a border and stuff in a second. So functionally, that's my first check. Do we have a direct order? Because the behavior is quite different depending on what the answer to that is. So let's say we don't. Let's say we're running some normal behavior. The next important piece of information is, do we have an attack target? Because if we don't, we should just go to our target point. That's kind of for patrolling and walking around, or if we just haven't seen anyone yet. And if we do have an attack target, we should be running to them and trying to attack them. So this check has no direct order. I covered what I mean by check up here. It's just so that if it succeeds something here, it doesn't then automatically run this. You need a safeguard. So if we don't have direct order, first of all, check, do we have an attack target? Versus check has no attack target. So the big check here is attack target versus no attack target. So let's come down the simplest train first. We'll kind of go lowest to highest. So let's say we don't have an attack target. We'll fail this condition, come back up to the selector, pick the next option. That's all nice and simple. So check has no attack target. This is now true. Notice with my checks, I don't bother putting abort settings on. So how the aborters work, you've got this notify observer. So the observer will observe, in this case of a blackboard, key decorator. So right click, decorator, blackboard. I'm saying key query, attack target is not set. So if basically it means is not null. So if I have an attack target, any attack target, this will fail, but if my attack target is none, this is true. So the observer, what it's observing is the blackboard key. So basically on result change of attack target. So if attack target was not set and becomes set in any way, or was set and becomes not set, that will trigger the on result change. The result change only fires when, so for example, if I had an attack target and I change it to a new, better attack target, that won't trigger a result change. That'll trigger a value change, which is the other option here. Now, just, I guess, to tangent really, really quickly, you'll see some of my setups has the exact same thing. So has attack target value change, has attack target result change. These are exact same node. I'm not sure if it's a bug. Value change at the moment doesn't call the abort if the result changes. So for example, here on has attack target, if I have, attack target Skeleton Warrior A, and I pick Skeleton Warrior B as a new attack target, it'll trigger the abort fine. But if I clear my attack target, my minions were just still doing their move to command, they weren't aborting, and they need to. So there's a couple of places where I've thrown on a double, so this has target point value change, has target point result change, has attack target value change result change. That's because, and here as well, that's because value change is currently not aborting when the result is changed. Again, don't know if that's a bug or intentional, but the workaround isn't even too ugly, you just put 2 there. If I could do custom decorators, I could listen for both, but that's another thing. So, coming back to where we were, attack target is not set. So check does not have target point. So again, this is just because we come down here, so we know we don't have an attack target, so we want to be walking to our target point. So the next question is, do we have a target point? So here is, again, we've got this double up here, but imagine that this is just one that does on value change and on result change. I wish it was just one, but it's not. So functionally this is, do I have a target point versus do I not have a target point? And the check here, again, just so that it doesn't automatically run that tree when it's done here. But so if I don't have a target point, we come down here and we call choose new target point and wait. And at choose new target point, this is where it hooks into, choose new target point is a custom task, and that actually hooks into my mini controller. So if we come down, commands, maybe, where is that? Choose new target point. Here we are. So choose new target point comes down and runs some logic here. Basically asks the minion, and then that comes into here. So there's some complex logic there about how I go about choosing my target point, but it's really nice wrapping those more complex things up just in a task. It lets you block out the logic on the behavior tree really, really nicely. So choose new target point, and I've put this in sequence with a wait. Sometimes I do that just as a safety thing. For example, if it chooses a new target point that is, if something's a little botching the logic, and it is, I just never want it to call something on tick, basically, if I can avoid it. So a 2-second wait isn't really that noticeable, and if it's something's gone botching the code or in the patrol node setup, I think if you put 2 patrol nodes within each other's move to radius of each other, sometimes it essentially chooses a new target point which has already succeeded, and it gets a little confused, but basically what this means, it'll just hit this wait node before trying again. It's just, I'm not sure if it's ever actually being called because the code is pretty stable, but I generally tend to put like little 2-second waits or something in just because it tends to not make it like hammer a point if something goes wrong. By hammer a point, when you actually play the game, you kind of see it running the track, and if it's running on tick, it flashes and it feels bad. So if I don't have a target point, really simply, choose a target point. The wait's just there to, the sequence obviously just runs everything in order. But really simply, if I have a target point, run this. If I don't, run this, and just choose new target point. And if I do have a target point, I start running this custom service. This is check if I'm at my target point. So this takes into account the, the radius of the patrol node and a whole bunch of stuff like that. And then we split off here, is not a target point, and then nothing on this one. So if we're not at the target point, move to the target point, really simple. And if this fails, it means that we are at the target point, so this will fail when this move to succeeds, because it'll be like, finish this task, what's my next task, it'll come down here again, this service will have updated, you've succeeded the move to, so it'll come down here, and then we choose a new target point. So really simple. When we get to our target point, choose a new target point. And now, again, just really quickly, the reason we have these two decorators here, the value change and result change, is if I give a move to command and they're halfway through it, and then I give another one, I need this value change because I need it to abort. Because it wouldn't necessarily just abort because this hasn't changed. I wasn't at my target point before, I've issued a new target point, the service runs, I'm still not at my target point, nothing's changed. But my target point has changed, and that's where this comes in, and that's where this value change will trigger an abort, it will recalculate, and it will rerun the move to with the new target point in mind. So we're still on the check for no target order. Next we come over to attack target, and we've got the same setup here with the value and result, because again, if I was attacking one person, and I suddenly start attacking another person, I need to abort my previous, or especially for the move to. If I had an attack target and I get a new one that's closer, I don't want to finish running to my old target, I want to swap over to the new one. And so we need this value change, result change on abort. So value change handles if I had an attack target and I get a new one. The result change, and this is, for a while I had the code, I set up the really simple invisibility thing. And even when I went invisible, they'd lose me as an attack target, but they'd finish walking to me before they went back to patrolling, which obviously looked bad, and it was because of this value result change thing. So again, basically the exact same logic here. Poll is in range of attack target, and this takes into account, again, this is all these custom nodes are kind of the complex AI stuff. This is polling your attack range and the radius of the things involved and a whole bunch of stuff, making sure that you can attack each other. So if we're in attack range, we want to either wait, or if we can attack your attack target. Can attack node is how I'm doing basically attack times. So you don't necessarily just want to make your guy attack off cooldown. You want to either bool essentially I'm shooting it like a cooldown. So when you attack, it starts a timer of your time between attacks, which is a variable in minion values, and then it counts down. And then after, the count, it sets it back to true. So it sets can attack to false, waits for the allocated time, and then sets can attack back to true. Really simple, so this, with the abort settings, you've got aborts none, self, lower, and both. Now, I haven't used lower at all. Probably a couple places where I could instead of using both, but I'm lazy and just use both. So really quickly covering that logic. So yeah, obviously, just to finish off my last point, sorry. If we are in attack range, check if we can attack. If we can attack, so if our attack's off cooldown, attack target again, custom node. If we can't attack, wait. Now for 99 seconds, this is because this is going to get aborted. When the minion's attack cooldown comes off, it'll set this can attack bool. This observer will recognize that its value's changed, and it will abort this way. Now, if we are not in attack range, move to attack range, and again, just in sequence of the wait, just in case, really. But functionally, this is just, if we're not in attack range, move to attack target. Covering the abort settings, again, really quick, these ones with check never have abort settings. You'll notice this is observer abort to none. I'm guessing it's more optimized if they don't do any aborting, because they don't really have to listen for things. They're just an if statement functionally. Now, the important one is always the higher one, because it aborts down the tree. So for example, let's say we were walking someone, let's say we were here, choose new target point, move to target point. We had a target point, we're not at it yet, we're moving to our target points, we're walking along our patrol node, and suddenly it sees someone. What happens is, our attack target goes from none to something. Now, it doesn't have attack target aborted here or here, but since this branches off the tree here, everything, so from here, you can actually see it. If I click on this, so if I click off, see how these are grey? If I click on this, this goes green. This tree is, itself, and this blue stuff is everything lower. So everything lower than this gets aborted when this, so this is listening for everything lower than itself. So even if we're down here, so if I click on this, you'll see that this is one of the nodes that goes blue. This is lower from that. So as opposed to, for example, stuff over here is grey. This is higher priority, doesn't care about these settings. So if my attack target result is changed, so this is the one that will fire when I get an attack target if I had no attack target, it'll abort this, which will cause the behavior tree to rerun. Still don't have direct order, we'll fail that. Direct order is not set, yep, true, passes that. This time it'll pass this, I do have an attack target set, and come down this tree. So that's kind of how this whole setup is working. Next we come over to the logic I have for the direct orders. So attack your target if it's in range, but main priority is moving to the new point. So this here has target value, has target point. These, I've put a border in front of them just basically to remind myself, but if I give you a command and then I give you a new command, you need to stop what you're doing and rethink about it. So nowhere down here, I was just going to have to put is it target point on every single one of these and make them abort self or something silly, so I just generalized it, put it up here. So functionally, has target point will always do true, because if you issued a direct order, the only way to issue a direct order at the moment, so set new target location comes with sort of facing direction. I've just gone, control rotation, ignore the pitch and roll of the character giving the order. The location is the hit location of this nasty trace, and then direct order yes or no. So really, really easy to use now that it's set up. So this is just for people wanting to know kind of how the AI is working behind the scenes. If you're just using it, just don't even worry, just that's easy to use. But these target points are for aborting the move to, any move to, if I give a new command. Otherwise I wouldn't give them here. So it has direct order, that is the important check here, and aborts both. So if we were doing something, if we were moving to our attack target, and we get issued a direct order, stop what you're doing, because obviously this is lower, everything's lower from up here, and aborts it. Now, I've done an interesting thing here. So you'll notice I've got this simple parallel node running, and I'll actually come down to where I'm using it properly down here, and then come back to where I'm using it kind of nastily. So really simple, basically you run the exact same, you basically run this, a modified version of it, again here. So you come down to this selector here, so yes, we have a direct order. The next question is, well, do we have an attack target? If we don't, this time we don't need to worry about all the logic about choosing new attack targets. If you have a direct order, so this will generally be used, move here in formation, get there in white. That's really, really simple. So if you're not at your target point, which is being pulled here, because if you have a direct order, you need to have a target point. So those checks are handy as well. And so the whole time we're running this code, we're checking whether or not we're at our target point. If we're not there yet, move to it, really simple. And then obviously the second we get to it, it'll rerun, it'll hit this 99-second wait. If I change where it is, this will abort that, and it'll go back. If we do have an attack target, again, the resultant value, just because, same as all the others, we do the same poll using attack range. I can just reuse that nice service that I made. And then, is it target point? And I've just split this logic, so if I'm at my target point, what I want to do, so simple parallel is really cool. Move to target point, and while it runs this subtree, and this time instead of being like, so it's basically the same attack logic, so this and this is basically the same. It looks a little different because here, if you're in attack range, you basically shouldn't be moving. You should just stand still and attack your target. It looks nicer than people constantly trying to butt up towards each other. Whereas this one, you basically want to keep moving while attacking your target. So if you can attack and you're in attack range, just wait, because this wait won't actually make it stop moving because it's just running while this move to is running. This move to is more important. So yeah, can attack, is in attack range, attack my target, otherwise wait. So that's how you get the nice kind of archer strafing backwards as he shoots at the warrior. If we're not at our target point, if we are at our target point, this is if we're not. It's the exact same logic. You'll notice this and this are identical, because this is just the code for attack something if I can, if not, sit still. and this here is not a target point, so the only difference here is if you're not yet at your target point, move whilst attacking something if you can. If you're at your target point, just attack something if you can without moving. So that's actually pretty simple. And down here, yeah, I already covered that. So now why I've put this through a simple parallel instead of just coming into a selector, I noticed something when I used the simple parallel properly here, that, so abort lower, this here is quite high off the tree because it's coming off this, which is coming off this, which means it's higher than everything down here. So, and aborts both meant that it would cancel anything here. And I'm reusing the same services and points, so this is not a target point boolean. Target point is, you know, still a thing. So basically the last thing I wanted was, it was just a neatness thing. If I had an attack target and I was moving to my attack target, and I get new target point set without the direct order logic, down here it doesn't matter, because these are lower priority. Everything to do with target points is lower priority than everything to do with attack targets. So it doesn't matter if my target point changes while I'm moving to an attack target. It's not going to abort or anything dumb because it's lower priority. Up here, it would. So even though this wouldn't be running because we don't have a correct order, I think the abort would still trigger because target point would get changed. Now, it still wouldn't be able to come down here because obviously direct order is not set, so it would still fail on this decorator. But what it would mean is it would abort the attack target, abort the move to, and then rerun it. And when you abort a move to, the character kind of like stops for a split second and then keeps moving. So what I really wanted was a neat way for that to not happen, otherwise they stutter step a little bit. So what I had taken to doing was basically just doubling up. So in a lot of places down here, you know, I'm setting is not at target point, abort both, and that aborts this. But I wasn't going to be able to do that because aborts both would have meant abort all this attack logic if the target changes, even if direct order wasn't set, which isn't what I wanted. So I wasn't going to be able to use this same aborts both, and this has no conditions at all because this will get aborted by this. So instead what I was doing was just to abort self. So basically the equivalent is here at this is not its target point. I would change the observer aborts to just a self, so it will just abort itself if that changed. And then I just put the reverse condition on this, which gave me a lot of manual control. So this would be is not a target point, and this one would be abort self if at target point. That way it can abort itself and it will rerun properly, but it just doubles up on nodes. What I found with the simple parallel node is it restarts the tree. So you'll notice if I click this, all of a sudden the only thing it will abort is this weight. So before I just had to put, you know, can attack and not in attack range on the weight, and I had to do it here. I had to put not attack target on this, and I had to do it in a bunch of places. So basically by putting a simple parallel node here, not running any main task, and then putting this on delayed, so wait for subtree, functionally what it means is I've just started an entire new subtree here that is a high priority for this stuff, but it doesn't abort it with the abort both. So instead of this aborting all of this stuff as well, since I've basically started a new tree here, this aborts both, now just aborts that weight, which is the same system I'm using down here, which is really neat. So that's pretty much the entire minion setup. Obviously, I don't really cover like how my services are set up, or the choose to attack target and attack and all that, because that's all just code in the controller itself, but that's a bit of a rundown. I struggled a lot trying to use the behavior tree for the first time, just because there's not that much information on it and it's a bit confusing. But basically, here's an example of a behavior tree setup that works, and hopefully that's helpful to some people, pretty much. And we got the cool behavior of being able to backpedal while shooting, which is awesome. And I like the formations, which look really nice, don't just immediately break and run the second they have a target now, which was kind of really important to them actually feeling good.